This video is for lesson 3.4, dividing rational numbers. So in this video, I'm going to be reviewing how to divide with fractions. Just like in the last video for multiplying, I'm going to show you a little visual first to help you hopefully understand better what happens when you divide fractions. Because again, just like in the last video, we discussed how multiplying two fractions less than 1 give you a smaller answer. Dividing two fractions or dividing a number by a fraction less than 1 actually produces a larger result. So that is kind of against what we learn when we first learn multiplying and dividing. We normally think when you multiply, you automatically get a bigger answer, and dividing, you automatically get a smaller answer. And that's just not true when you're working with fractions and decimals and things less than 1. So this is a visual to help you with that. So take a look at these two blue rectangles. So that's going to represent, this is going to represent 1, and this is going to represent 2 whole. So we're dividing these two rectangles by 1/3. So what that means is I'm dividing each rectangle into thirds. So now we have a total of 6 pieces. And what I'm going to be what this question is asking is, how many pieces do I end up with when I divide each or 2 rectangles each into thirds? So the answer to this problem is actually 6, which is how many total sections we now have when we divide each rectangle into thirds. So you see the answer is a bigger number than what we started with, but what it doesn't tell us is that each of those 6 spaces are smaller than the 2 individual holes that we started with. So that is why we get a bigger answer, and that is often confusing because we think, well, if we're dividing things smaller, why would we get a bigger answer? Well, and that's because each piece is smaller. So you have to think about that when you are not sure if your answer is reasonable or not. Okay, so how do I do a division with fraction problem? You probably remember learning keep, change, flip, and that is where this is where we use that. But first, before we keep, change, flip, we still have to, number 1, convert all mixed numbers to improper fractions. So you have to do that first before keep, change, flip. And then step 2, it says change division to multiplication and flip the second fraction to its reciprocal. That is our keep, change, flip. So I will write that, keep, change, flip. And then once you do that, you are going to simplify to make sure your answer is in simplest form. This has to happen for every single question. Don't forget. Here you go, keep, change, flip. Okay, so just a quick reminder, what the reciprocal is if your original fraction is 9/10, the reciprocal is 10/9. Now that we're going to be working with negatives, if the original fraction is -3/7, the reciprocal is just -7/3. So we still have a negative fraction, you're still just flipping the numerator and the denominator. Okay, so in your notes packet in the next column where it says division, you'll see these 2 examples. So we start step 1 by converting any mixed numbers. We don't have any here, we just have one whole number, but we can put a 1 underneath there. Basically, all you need to do for this one, since we don't have any mixed numbers, is keep, change, flip. So we're going to keep the first, change division to multiplication, and flip the fraction, -4/1 to -1/4. You can, at this point, check for cross simplification. You cannot do it in the original problem. So just to clarify, you can only cross-simplify once the problem has been changed to multiplication. Since 5 and 4 and 1 and 6 have no common factors, now we just multiply the numerators, multiply the denominators, and we get 5 times 1 is 5, 6 times 4 is 24. Now I forgot to do this before we started, but a positive times a negative is going to be a negative. Check to see if there are any common factors to be simplified, and since there are not, our final answer is negative 5 over 24. In this example, we're going to start by step 1, converting both of these mixed numbers to improper fractions. So 3 times 5 is 15, plus 4 is 19. So this is negative 19 over 5. I am not going to flip this just yet because I am not changing the problem. I'm not doing keep, change, flip yet. I just need to first convert this mixed number to an improper fraction. That's a very common mistake, is that we want to change this to multiplication, but you need to convert this to an improper fraction first. 1 times 5 is 5, plus 3 is 8. So we have negative 19 fifths divided by negative 8 fifths. Negative divided by negative is going to give us a positive answer. I still need to keep, change, flip. So let's do that. Keep, change, flip. Again, at this point, after I keep, change, flip, I can look for cross simplifying. Both 5 and 5 can both be divided by 5. Let me do this in red so it's a little more clear what I'm doing. 5 divided by 5 is 1, and so is this 5 divided by 5. Now that I've cross-simplified, I can finally multiply the numerators. 19 times 1 is 19, and 1 times 8 is 8. We already said the answer would be positive, since negative times negative is positive. Again, you can leave your answer as this improper fraction, that's fine, or you can write it as a mixed number. 8 goes into 19 2 times. 8 times 2 is 16, so that means 19 minus 16 leaves 3 left over with a denominator of 8. Okay, I'm going to have you try this example by yourself. This is not on your notes. Give it a try. Step 1, you're going to convert to a mixed improper fraction. 1 times 3 plus 2 is negative 5/3. And before I do keep, change, flip, I highly suggest just rewriting the problem with no mixed numbers before you try keep, change, flip. Sometimes when people try to mix or combine steps, that's where we end up making mistakes. So now I can keep, change, flip. Negative 5/3 times negative 8/7. And again, once you keep, change, flip, we can look for cross simplifying. There is no cross simplifying that can be done here. So we just multiply 5 times 8 and 3 times 7. 5 times 8 is 40, 3 times 7 is 21. Negative times the negative is going to be positive. And there are no common factors between 40 and 21 that I can simplify. So I can leave it like that, or I can convert this to a mixed number. Okay, and just like in the last video, I just want to take a look at 2 word problems so that we can look at some keywords that will help us determine when division will be used when working with fractions. Rachel has a tub that holds 10.5 gallons of water. The small container she is using to fill the tub holds 1 3/4 gallons of water. How many times will she need to empty the small container into the tub until the tub is full? This one can be a little bit tricky because the key terms here are how many times, which if you don't read it carefully, if you just look for the word times, you might think that's multiplication. But basically you need to know how many times, so you're going to fill that smaller bucket. So 1 3/4 times blank equals 10.5. Well, we don't know that information. So to figure that out, we have to divide 10.5, which is my total, divided by 1 3/4. And so basically, if we're missing that information, we need to work backwards. So the opposite of multiplication is division. So that is why this one would be division. In the second example, a stack of tiles is 17.5 inches tall. If each tile is 1 1/4 inches thick, how many tiles are in a stack? The key word here is each tile is 1 1/4, and similarly to the one above, how many tiles, knowing that each one is 1 1/4 inches thick. So this is similar to the first example. 17.5 is the total height divided by each one to figure out how many there are. Okay, and that is the last example in dividing fractions.